When you think about massive companies like Netflix or Uber or even LinkedIn, they all share a common, massive challenge. How do you handle these insane, chaotic streams of data all happening in real time? Well, for many of them, the solution involves a ridiculously powerful tool called Apache Kafka. And in this explainer, we're going to demystify it. We'll break down what Kafka is, why it's so darn important, and how it takes that data chaos and turns it into clean, controlled, orderly streams.
Okay, let's start with a scene that I'm sure is painfully familiar to just about everyone. It's a huge sale, Black Friday, Cyber Monday, you name it. You've got the perfect item in your cart, you hit checkout, and then nothing. Just a spinning wheel. The website completely freezes. You're just staring at the screen, getting more and more frustrated, wondering if you just lost that deal. For you, it's annoying. For the business, it's a potential catastrophe.
So why does that happen? Well, to get to the bottom of it, let's picture a little e-commerce startup we'll call StreamStore. When you place an order, it's not just one thing that happens. It kicks off a whole chain reaction. The system has to update the inventory, send you a confirmation email, generate an invoice. It really is like a line of dominoes, where one action has to perfectly trigger the next, and the next, and the next.
Now, in StreamStore's first attempt at building this, each service talks directly to the next one in line. The order service calls the payment service, which then calls the inventory service, and so on. This kind of setup where everything is directly connected and waiting on each other has a name. It's called a tightly coupled system. And if the payment service, for instance, gets bogged down during that huge sale, what happens? Everything behind it grinds to a halt. One domino gets stuck and the whole system just collapses, leaving customers hanging and sales disappearing into thin air.
So the folks at StreamStore had a big realization. This whole frantic game of hot potato, where each service is desperately trying to pass data to the next one, it just wasn't going to cut it. It was too fragile. They needed a totally new way of thinking. They needed to move from that chaotic game to something more like a calm, organized conveyor belt, where each task is handled one at a time, independently.
And that is where a tool like Apache Kafka enters the picture. It's brilliant, really. Just think of it like a digital post office for all your application's data. Instead of every service running around trying to deliver messages to each other, they just drop them off at this one central hub. And Kafka? It takes care of the rest, managing the whole flow of information.
So sticking with our post office analogy, any part of your app that sends information, well, that's called a producer. When our order service gets a new order, it produces a little data event that says order placed, and it just hands it off to Kafka. It's literally like dropping a package in the mail.
And here's the really crucial part. That producer, our order service, it doesn't have to hang around and wait for delivery confirmation. It just drops off the package and trusts that the post office, Kafka, will handle the rest. This frees it up to immediately get back to work on the very next customer order. The whole system becomes faster and way more responsive.
All right, so this is starting to make sense. We've got producers sending all this data, orders, payments, you name it. But wait a minute. If you just dump all that mail into one giant pile, wouldn't that just be a different kind of chaos? How on earth does Kafka keep everything from getting mixed up?
And you'd be right. That's why Kafka has a really clever way of organizing things. It uses something called topics. This is exactly like the sorting room at a real post office. You don't just have one big bin for mail, right? You have separate sections for letters, for big packages, for returns. Topics do the exact same thing for your data.
So for our StreamStore, you, as the engineer, would get to decide what these topics are. It's super logical. You'd probably create an orders topic for all new order events, a payments topic for anything related to payment status, an inventory topic. You get the idea. It creates this beautifully clean and organized flow for every piece of data in your system.
Okay, so we have the senders, the producers, and the mailroom is organized into topics. Now we need the receivers, right? In the Kafka world, we call these consumers. These are your other services that are interested in specific types of packages. They just subscribe to a topic, and Kafka makes sure they get the mail they're waiting for.
And this is where the magic of decoupling really shines. When that order-placed event lands in the orders topic, it's not just for one service. Multiple services can be listening. The notification service sees it and fires off a confirmation email. At the exact same time, the inventory service also sees it and updates the database. And the best part? They don't even need to know the other one exists.
Okay, so our system is way more organized, way more resilient. But let's go back to our original nightmare scenario, Black Friday. Can this new setup actually handle the heat when millions of orders start pouring in all at once? Can it actually scale?
This is where Kafka's true genius for scale comes into play. It has this incredible feature called partitions. So if a topic is a sorting section in our post office, you can think of a partition as adding more workers to that section. It lets you split up the work, allowing you to process all those messages in parallel, which dramatically boosts performance.
And the impact here is just massive. I mean, look at it. By splitting a single topic into, say, 4 partitions, you can basically handle 4 times the data. Split it into 8, you can handle 8 times the data. This is exactly how Kafka can process millions, even billions, of events without even breaking a sweat.
All right, so our post office is now a well-oiled machine. The workers are sorting mail like crazy. But what if all that mail is still going to just one person? What happens if our single consumer gets totally buried under this mountain of messages? We've just moved the bottleneck, haven't we?
And you're right, that would be a bottleneck. But Kafka has a solution for that too, and it's called consumer groups. It's a simple idea with powerful results. Instead of running just one copy of your inventory service, you can run a bunch of them. And Kafka is smart enough to see they're all part of the same team, so it automatically splits the work between them.
So let me walk you through how this works, because it's pretty slick. Imagine you've got one consumer, and it's just getting hammered, can't keep up. So what do? You just launch a second copy of that service with the same group ID. The moment it comes online, Kafka sees it and automatically rebalances the workload. It says, okay, you take this half of the partitions, and you take the other half. Just like that, you've doubled your processing power. It's effortless scaling.
So at this point, you're probably thinking, okay, I get it. Kafka is just a really, really good, super scalable message queue. And yeah, you're not wrong, but you're also not totally right. There's one more feature that absolutely sets Kafka apart from everything else. It's the real secret sauce.
And this is the real game changer. You see, most message queues, once a message is read, poof, it's gone, deleted. But not Kafka. Kafka holds on to every single event. It creates this durable, ordered log of everything that has ever happened in your system, and you get to decide how long to keep it. A day, a week, a year, even forever.
Think about what that actually means. A traditional message queue, that's like live TV. If you're not sitting on the couch right when your show is on, well, you missed it. It's gone forever. Kafka, on the other hand, Kafka is like Netflix for your data. You can watch the stream of data whenever you want. You can pause it, you can rewind it, you can even have a brand new service come online and re-watch the entire history of events from the very beginning. And this superpower, this ability to hold on to data, it's not just a neat trick. It unlocks some seriously powerful capabilities. You can build real-time analytics dashboards that are always up to date. Or, get this, if one of your consumer services has a bug and messes up some data, no big deal. You just fix the bug, rewind the topic, and replay all the events it missed. It's a level of fault tolerance that's just incredible. So when you shift your thinking away from these disposable, one-time messages to this idea of a permanent, replayable log of everything that's ever happened, well, it completely changes how you can build applications. It makes them more robust, more resilient, and more powerful. And it leaves us with one big question to chew on. What could you build if you knew, for a fact, that your data could never be missed again?